Is Tanmay Gupta, and today I'll be discussing my Physics 2212 Lab 3 Magnetic Field of a Bar Magnet. Moving on with the introduction. The purpose of this lab was to observe and better understand magnetic fields through a visual representation, to visually observe the relationship between distance and magnetic field, and to use the distance dependence of magnetic fields and the Biot-Savart laws to find the magnetic moment of a permanent dipole magnet. The fundamentals I used were modeling a bar magnet as a dipole to model its magnetic dipole, and the Biot-Savart law for dipoles, which is given to the right over here, and then the distance dependence formula of a bar magnet. Note that k in this equation is a combination of constants and parameters which does not change during the experiment. We seek n using this equation. The following were the results. The magnetic dipole moment came out to be 2.21 amperes into meter squared, and then the value of n came out to be minus 2.5. The assumptions and models. As previously mentioned, we assumed the bar magnet acted as a magnetic dipole in order to apply the Biot-Savart law. Moving on with the experiment. The system of the experiment was the bar magnet itself, and the surroundings were everything else. A magnetometer on the phone was used to measure the magnetic field. First, the location of the magnetometer on the phone was pinpointed by sliding the phone perpendicularly to the ruler, both vertically and then horizontally, with the bar magnet on one end of the ruler, in order to see at which position of the phone relative to the magnet the strongest magnetic field was being read. And then, on the axis distance from the bar magnet to the magnetometer was found using the ruler for several different magnetic fields. Because these values were exponential in nature, they were linearized by taking the natural log of each side and then graphed as shown right over here. This is the equation of me converting the exponential equations into logarithmic equations. Finally, the off-axis magnetic field of the bar magnet was found. Following with the observations. When the magnetometer is far away from the magnet, T measures a near zero magnetic field in the x direction. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases, and then there should ideally be a cubic relationship because electric field and magnetic field due to dipole is proportional to 1 by r cubed. The position of the phone matters in terms of ensuring that the magnetic field of the Earth does not interfere with our readings for the magnetic field of the bar magnet. These were the calculations I made. The distance dependence equations are given below. And then we know that n is the slope of this equation, so therefore it is minus 3.043. The ln of k came out to be 14.633, whereas k was 4.42 to the power negative 7. Using Biot-Savart law to find mu, we set the condition of r to be 1 meter, and then the Biot-Savart law came out to be mu is equal to 2 pi k into r to the power n into r to the power cube upon the initial mu. Through this, our magnetic dipole came out to be 2.21 amperes into meter squared. Following where the glow script models are developed to further help me code through this equation. We can see that there was a magnet. The magnet was formed in this part of the equation, while in the arrows in the magnetic field was measured in this part of the equation. We also see a cute welded message being printed at the end when the code runs perfectly. This was the result of the code. We see that the theoretical off-axis field was 2.7 into 10 to the power minus 5 Tesla, whilst the experimental off-axis field was 6.36 into 10 to the power minus 5 Tesla, about an 81% difference. So, discussing this, there were some model discrepancies. A bar magnet's magnetic field typically very closely models that of a magnetic dipole. So, in this case, our choice of model likely yielded very accurate results. Although there were sources of error, like the location of the magnetometer on the phone may not have been found very precisely, or the reading of the magnetometer did not match Earth's magnetic field before the experiment began exactly. Moving on to more discussion. What if I hadn't oriented the experiment to compensate for magnetic north? I think that my results would have been much less accurate, and then because the magnetic field would have interfered with my reading and skewed the results. Also, what if I were to stick two identical magnets together end to end and run the experiment again? I believe that the measurements would have roughly doubled as the magnetic field at a location relative to the two bar magnets would have roughly doubled. To end, both the Biot-Savart law and the distance dependence can be applied to bar magnets with accurate results, and bar magnets can be used to accurately model magnetic dipoles. Distance is an important factor to consider in determining the strength of a magnetic field. Thank you so much.